Sarge joint. So they'll translate over the top of the lab. They'll then come down to the bottom part of the truss and take these handrails that you see flashing along the nadir edge of P1 all the way out across P3 to the port Sarge. And then the covers that you see flashing on the port Sarge are the covers that they will be working together to remove to provide access for Shane to lubricate that outboard race ring on the port Sarge. And would mention that on the port Sarge we're lubricating only. There will be no cleaning or no trundle bearing changeouts. And here you can see the three areas where those covers are located that will be performing that lubrication. Now, once Shane has completed the first round of lubing, we will perform a 180-degree rotation. What will happen then, you can see these beads, the gray beads on the surface of this ring. This is a race ring in a test. You can see how the trundle bearing, as it rolls along, it spreads that bead out, and it carries it actually for about another 30 degrees, or a little more than that even, beyond the section that the grease was originally applied to. So that's what's going to be happening during this 180-degree rotation that you see here. So that grease will be carried by those trundle bearings from the alternating sections where it was applied, and it will give us a good even covering of that entire 180-degree segment of the port Sarge race ring. While that rotation is taking place, Shane will translate back into the inboard lower side of P1, where there's a camera stanchion that is already installed, and he will just be installing a camera there. He'll translate back to the airlock to retrieve the camera, bring it out. There's a dummy box that he'll remove on his way back to the airlock, and then when he gets back with the camera, he'll install it on that stanchion, and then there's 3 electrical connectors that he will attach to provide power to that camera. Once that's complete, he will translate back out to the port Sarge and lube under those same covers that the first lube was performed under. While he is doing that work, Steve will be translating forward again back out to the gym to reinstall that center disc cover on the EFBM mechanism that you see here. That's that large circular disc. Once Steve is complete with that, he will and here we see Steve in the NBL practicing the installation of this disc. There are quarter-turn fasteners on each one of these tabs that wrap around the corners. There's also Velcro on there that Steve will use to resecure that cover onto the berthing mechanism, and that will protect some connectors and fluid umbilicals that are located in the center of that mechanism. Then Steve will translate over a few feet to the forward side where the gym RMS will be waiting for him. Sandy Magnus will be standing by inside if we need to maneuver that arm to position it for access to those grounding tabs, and then Steve will tuck those grounding tabs out of the way and secure them in place. And here you see flashing the 3 handrails and 2 whiffs then that Steve will install on the port end cone of the gym. He'll translate up as he is installing those and then continue on up to the very top of the gym logistics module for the installation of the GPS antennas. You can see some 2 areas with white MLI patches. That's the 2 areas where the GPS antennas will be installed. There's a dovetail fitting. Where these antennas attach, they utilize the same interface that the on-orbit installable whiffs use, and then there's 2 electrical connectors that are mated for each antenna. And here's the location for those, and here you see Steve in the NBL installing one of these antennas on top of the logistics module. And when he's complete with that, he'll translate back to the PMA1. You see a foot restraint to his right. He will reconfigure that, get into that foot restraint, turn around and look back toward the S1 radiators. And we will have that positioned at an angle such that the radiators are kind of broadside to him, and he will use both his regular EVA still camera and the IR camera to take imagery of all the panels on this radiator. We'll then rotate that radiator so and he'll take imagery of the other side of the radiator as well. He'll then turn around toward P1, and we'll do the same thing on the P1 radiators. It kind of depends on how the EVA times out as far as which set of radiators we'll do first. If things are going very well, we will probably go to the P1 radiators first. That'll get that targe beam back in position and locked so that if Shane has time at the end of his activities, he can perform some get-aheads that we need that targe locked for, and then we would perform the S1 radiator imagery. Now I've got a couple of graphics that I'll show you to detail how this lubrication process will work on the port sarge. The first graphic shows the area of the 6 covers that will be removed. Covers 6 and 7 at the very bottom of the graphic. Covers 10 and 11 on the kind of the bottom left, and then covers 14 and 15. And then those areas in red you see here are where Shane will apply the first lubrication to the port sarge. Now our next graphic shows how that lubricant will be spread during that 180-degree rotation. That rotation will be in the clockwise direction. So the solid areas that you see in red on the right are where the lubricant was directly applied. The dashed areas are where that lubricant will be spread to as the sarge is rotated that first 180 degrees. And then Shane will come back and perform the second lubrication in the areas that are shown here in solid blue. And then the next rotation of the sarge will do the same thing. It will spread that lubricant that is applied in the areas shown in blue here to those remaining areas and completely lubricate that outboard race ring of the sarge. I mentioned a couple of times that we've got additional tasks that we can perform if things go well. I'll just talk a little bit about those. One of those tasks is disconnect of some bus bolt controllers. This is just an electrical connector that we could disconnect from a panel and park it over on a dummy connector. These are the controllers for the motorized bolts that attach the S1 segment and S3 segments together, and also at the port end the P1 and P3 segments. We have left those connected up until now so that we can monitor on the ground the condition of those bolts. We have now got all the data that we need from those, and those units are ready to be disconnected at our earliest convenience. So that's a good, convenient task because it's out near the sarge areas where the crew is working, and it's a fairly short task if we've just got a few minutes left at the end of an EVA. Another task that would be a possible candidate would be installation of some fluid jumpers. These are down on face 6, the lower face between the S1 and S3 trusses again, and the P1 and P3 trusses. These are some jumpers that we would put in place in preparation for a maintenance task down the road if we need to perform an ammonia fill on the outboard truss elements. Again, it's in the close proximity to where we're working on the sarge, which makes it a good candidate task for us. There's also some clamps on the intersections of the P1 and S1 trusses near the FHRCs that we would release. Those clamps were needed for launch to hold some fluid lines in place. They need to be released if we ever do remove and replace an FHRC. Those are another get-ahead task that we may look at if we have time and things are going well with the sarge cleaning. If things were going exceptionally well with sarge cleaning, we might consider deploying one of the payload attachment systems on S3. The crew has been trained to do that, but things would have to go really well for us to be able to get that done. And that completes my description of the tasks that we'll be performing on these 4 EVAs. The next thing I'd like to talk a little bit about is the gloves that we'll be using on these EVAs. We're flying a redesigned thermal micrometeoroid garment on these gloves. This will be the first flight of this garment. We have a picture here that where you can see these gloves. The only noticeable difference on the exterior of these gloves is that the RTV on the palms is a darker gray than the previous gloves that we used to fly, and that's because this is a different formulation of RTV. These gloves also have a layer of turtle skin that is sewn in between the molded palm of the glove and the RTV. So although it's not visible on the finished assembly of the glove, you can see here where those turtle skin patches have been applied, and those are in the high wear areas on the index finger and the thumb of the glove. And I have one of these gloves with the new TMG on it that I can show you here. This is Shane Kimbrough's training glove. Our crews have been, Heidi, Steve, and Shane have been training with gloves that have this redesigned TMG on them in the NBL to give them experience to see what the gloves feel like, and also to give us data on how the gloves will wear. So some of the improvements, the turtle skin here provides additional cut resistance in the high wear areas along the thumb right here and along the index finger right in here. This is where we have seen damage in the past. The darker RTV gives us better peel resistance, as we call it. One of the areas that we have seen damage to the RTV on past flights is right along the edges here. We'll see that RTV tend to peel loose from the Vectran layer underneath.